Welcome to the XES eiConsole for DTCC Product Quick Tour. Whether your organization is sending or receiving DTCC supported data formats, and regardless of whether you're using the widely adopted IPS file layouts or the emerging Accord TX Life web service transactions, the XES eiConsole for DTCC provides a rich suite of tools to facilitate implementation, reduce project timelines, and to control cost. When first launching the XES eiConsole for DTCC, the Route File Management window will be displayed. This depicts all of the interfaces and interface templates in the developer's local working directory. The eiConsole for DTCC includes pre-configured interface templates for each and every one of DTCC's supported data formats. Creating a new interface that produces or consumes these formats is as easy as selecting the appropriate template, copying, and configuring. Double-clicking an interface exposes the main route grid. This depicts the paint-by-numbers flow of an interface from one or more defined source systems to one or more defined target systems. The developer's job is to work through each one of these defined stages in turn, configuring the desired behavior. A source system will make data available to a listener, which can then either passively or proactively acquire that data in whatever format the source system desires. The developer simply chooses the appropriate listener type and then configures the displayed configuration options. After data has been acquired by the listener, we move on to the processor stage. The processor stage lets us do general work over the data stream, such as decompression, decryption, specialized logging, or, finally, DTCC-specific validation. We then move on to the source transformation, where data is taken from the format of the source into a canonical model for that transaction type. In this case, the source system will be producing IPS flat file app sublayouts. This data will be translated through a transformation module into an XML representation of the app file. That XML representation of the DTCC app subformat will be used as our canonical model. This transformation module can be used to translate any non-self-describing data into an XML format. XSLT is then used, if required, to logically map that data onto the desired canonical model. In this particular case, the app XML will be used as the canonical and no XSLT will be configured. We then move on to the routing stage. The routing stage allows us to define routing rules, wherein, had we had multiple targets defined, we can determine which data should be sent to which target or set of targets. The routing pane also allows us to configure transaction monitoring. Transaction monitoring is the XES eiConsole mechanism for proactive error notification. Common examples include email or SNMP trap. For each defined target system, there may be a target transform. The target transform is used to take the data from the canonical format and to translate it into a format that can be consumed by the target system. In this case, we'll be taking our app XML file and doing a translation into an XML representation of a SQL update. If further translation to a different data representation is required, a transformation module can be used. For instance, the delimited and fixed width file transformation module may be used to generate a DTCC IPS file layout. Finally, the transport stage is used to handle connectivity to the target system. Just like the listener, we have a wide variety of transport types supported. Select the one appropriate to the target and configure. The target system then receives the data, either in a batch mode or in real time. Should the target system provide an immediate response, the transport will then take that response data and pass it along to a subsequent route, which will handle the processing of that response. Once a developer has completely configured the route, they'll switch to the XES eiConsole's testing mode. In the testing mode, the developer can start a test at any stage and end a test at any stage, with arrows indicating the path the data might take. Clicking the Execute Test button will display a dialog which will allow us to provide sample data for our test. In this case, we'll provide a flat file app sample. As each stage completes, the question marks in the screen will turn into either a check mark for success or a red X for failure. We can then look at the performance of the stage as well as the data as it appeared at each point in the process. Here, we started with an app file, which was translated automatically through our flat file transformation module into an XML representation of the app sub format. That data was then further translated into a database insert into a table called entities. Finally, that insert was executed against a relational database. Once the developer is comfortable with the outcome of their test, they'll return back to the file management window. This will allow the developer then to deploy the interface to the separately licensed XCS EI Platform runtime component. Now that you have an overview of how the XCS eiConsole works, let's take a closer look at how the XCS eiConsole helps you specifically for DTCC-related transactions. The XCS eiConsole supports the capability of taking IPS file layouts from XML into a flat file or from flat file into XML. The delimited and fixed width file transformation module, supported by the file specification editor, is what supports this capability. The tree on the left-hand side of the screen shows the pre-configured layout of an app subfile. Green records representing loops, blue records representing fields. Any DTCC layout of any version can be read in using the import from DTCC format capability. Simply point at the appropriate XLS, the spreadsheet published by IPS, click Open, and the data will be loaded into the left-hand side of the screen. Once loaded, this tool has the capability of taking a flat representation and translating it into the structured XML that we can then map. This same tool can be used to take the XML representation that we may generate and automatically handle all the formatting required to place the file in the appropriate fixed width layout. We can go from an XML structure into a flat file. All tedious parsing or creation of these formats is eliminated. Of course, the tool can be used not only to handle DTCC formats, but any other fixed width or delimited format that you may need to parse. Moving on to the target transformation, the XCS eiConsole generates XSLT to represent logical mappings. This XSLT is created in a best-of-breed data mapping tool called the XCS Datamapper. The XCS Datamapper is a three-paneled mapping tool. We have our source format on our left, our target format on our right, and our logical mapping represented in the middle. When loading in the source format, the XCS eiConsole for DTCC highlights the DTCC format builder, as well as the Accord Life schema release format builder. The DTCC format builder again allows us to consume those IPS layout spreadsheets. Select the format reader, choose your desired format, and click Read Format. The tree on the left-hand side of the screen will be populated with the appropriate DTCC layout. The DTCC tab will provide searchable documentation for each one of the fields within the DTCC layout that you're working with. Additionally, when working with a field that has a code list associated, a Codes tab will appear. These codes can be used in conjunction with the XCS eiConsole's tabular mapping tool to very easily generate mappings between two sets of enumerated values. Mapping in the Datamapper is as simple as drag and drop. Select a field you'd like to add from your target, drop it on the appropriate parent, and then choose the corresponding field in your source. Now let's take a look at how this applies to DTCC's Accord TX Life transactions. For each one of DTCC's emerging Accord TX Life transactions, we provide a transaction template. The transaction template includes DTCC's desired SOAP envelope, as well as a version of the TX Life transaction payload. Just as the DTCC documentation for the IPS fixed width file layouts were available inline, the Accord documentation is also available when mapping to or from an Accord transaction. The Accord tab has the Accord-defined or DTCC-defined description and definition. Again, when working with type codes, a Codes tab appears with the code, code name, and code description. Developing a new Accord transaction is as simple as reading in your source format using the source format readers, and then mapping onto the map in the middle. Finally, the XCS eiConsole for DTCC includes a specially developed MTom processor. The MTom input and output processors allow you to quickly either generate or consume DTCC's required MTom attachments. Like with any other processor in the XCS eiConsole, simply select the appropriate processor during the listener or transport stage, and fill out the required configuration information. We have seen how pre-developed Accord and DTCC interface components can dramatically reduce the learning curve required to take advantage of DTCC's current and emerging offerings. Months of implementation effort are certainly eliminated, reducing budget and resource constraints that may have previously prevented valuable projects from moving forward. This concludes our quick tour of the XCS eiConsole for DTCC.